So what we are going to cover basically in this module is try to understand what are operators, why they are used, and there are different types of operators like assignment operators, arithmetic operators, comparison operators. As you might have heard, I've mentioned comparison can also lead to Boolean results, that is in true or false, used with if statements. We'll see how it goes. But then there are logical operators, bitwise operators, identity operators, Python membership operators, and we'll see some concepts which are popular regarding the operators. Uh, and their foundations actually go back to the BODMAS rules. Like we see precedence and associativity, we'll see how mathematical things are used in Python. First, we'll see arithmetic and assignment operators. So, what basically operators are? They they specify relations, or they carry out operations between two variables. Like if you are using a plus operator, it is used for addition. The minus operator is used for subtracting two values. So there are some examples of operations. So you can carry out a calculation or simply an assignment. Like if you're using an equal to with slight variation, we'll see how it is. That is also an operator, right? Anything which comes between, it says two operands, right? So now operands can be two variables like a or b if they have two values, like if a is 5 and b is 10. So if c is a plus b, so plus is the operator which is coming between a and b, right? So that is an example of an operator, the plus symbol. So again, these three broad types in this section, we'll just quickly see all these six types. So uh, assignment operators are used to assign values. So equal to is again one example. It's the simplest one, but there are variations with this. So you can do two operations at a time. So one example is, as you can see on the screen, it's plus equal to, right? So if uh, you can use it with one variable plus equal to, it does assignment as well as addition for you. So what it does is it uses x two times. So now what is happening is x plus is equal to 5 is actually same as x equal to x plus 5. Now this variable x can have maybe having a value previously. Okay, so now you are adding 5 to that previous value and assigning it to x again. Now value of x has changed. For example, if x value was 10 before, so x plus equal to 5, which is x equal to now 10 plus 5, the new value of x will be 15, right? So similarly, we can use minus equal to, divide equal to, and there are certain other variations as well for this. So so these are again arithmetic operations, plus, minus, multiply, divide, and just now we saw modulus operator, which will give you remainder between two values, right? So if uh, you say 3 modulus 2, this percentile thing, so 3 percentile 2, 3 modulus 2 will give you the remainder, which is 1. Okay? So that is how it is used. So similarly, we have this 2 stars, which is exponential operator. So now a uh, with this operator with exponential 5, if a is has some value already, will be raised to a power of 5, right? So if a, for example, has a value 2, so 2 to power 5, the result will be 32. Similarly, there is this a floor division. You can see double backslash here, which gives the quotient. as a result on division between two variables, and it off, right? So
I'll just ask a quick question
if
here.
yeah, yes,
Let's see who answers this first. If I say 5 double backslash 3, what is the answer that you're going to get? The symbol that you're seeing here, 5 double slash 3. Five double slash 3. Why do you think it is 9? Okay, this is something you should know. You can try it in Python parallelly. Try it out.
yeah,
What is the number that you are getting? Check it in Python and let us know. 5 double slash, the number, the symbol that you're seeing there. Nope, 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 nope.
it
Nandu
should
says
give
1.
you the quotient. Yeah,
1 is the right answer. You checked it in
yeah,
Python? That
yes.
is important, boss. Try it in Python. First, understand the concept and apply it in Python. Good, Padmavati. Good that you did that. Good. So, I mean, please, I mean, this is what you need to do quickly. Learn, apply it in Python, show it in, I mean, try it in Python, and then quickly come up with the answer. Such things. Instead of using calculator, you should use this one. Python as a calculator, kind of. Yeah, back to you, Kaushal. Yeah.
Yeah. So as we see quickly, it should give you the question, right? Question. So 5 divided by 3 should be 1 should be the question. So if one of the values is negative, things slightly they will change. So it will round it off to the other direction. So 11 divided by 3 should give you 3 point something, right? So instead of rounding it to 3, it goes to the other direction. It goes to the negative direction and rounds it off into -4, right? So that changes when you have one negative value. So percentile, as we saw, gives the remainder of division between two operands. That is the modulus operator. So now we go to comparison and logical operators. So basically, these operators are used to compare two variables, which have we can have any values, right? So you uh, these operators will give you boolean values as output. So if I say 5 is greater than 3, it can have only one output, which is true, right? So that is what you get from this comparison operators: greater than, less than, double, equal to. We will see that. So these are the examples. You can quickly have a look at these. So double equal to will check if A is equal to B, right? So A equal to B is returns true if A is equal to B. And then X using this operator is not equal to exclamation mark equal to. This checks if A is not equal to B. So yes, sir, you say something. So A not equal to B will return true if A is not equal to B. So it works the other way. It is actually opposite of the first one. So similarly, you have this greater than.
1 second, Kaushal. I think there is a question from Padmavati.
Okay.
3.666, the initial one that you gave, like, what are we getting
Right.
4? She's asking.
This one, right?
This is the one, right, Padmavati?
Yes, sir. Yes, this is the one.
Okay. So one value here is negative. So if this value is positive, so if this was 11 floor division by 3, this should give you 3.66, which will be rounded to 3. Whatever is the decimal value, it should give you 3. But when it is a negative value, it will not go that direction. It will go to the negative extreme. So it rounds it off to it rounds off to -4, right?
So Padmavati, which is the lowest number? -3 or -4? -4, right? You take the lowest number. If it is +3,
Yeah.
let's say for example, +11 divided by the double \3 means it would have been 3.66. 3 or 4. These are the two extremes, right? So 3 or 4 means you'll take the lowest number, 3. Same way it is -3 or -4, which is the lowest number, -4. That's the reason. And continue question. Sorry for interruption.
Yeah. No problem. So moving on. We were at the greater than, less than. So these operators are again examples of comparisons you can make between two values, A and B. And then if you can check greater than equal to also. So if it is even equal to it, that will return true. Less than equal to is similar. Then we have logical operators. So these are basic operators like and, or, and not. So you can see the AND gate. So now both the values for the AND gate, like if you supply them binary values, it should be both should be 1 for the result to be 1, right? So if any of these is 0, the result will be 0. That's how the AND gate works. And for the OR gate, if any value of A and B is 1, the result will be 1. Doesn't matter. So if both are 1, again it is 1. And if any value is 1, it will be 1. NOT gate is then it gives you the reverse of whatever you're supplying. So if you give, if A has the value 0, not A will be 1. And if it has 1, it will be 0. So this logical tables again emphasize the same thing. You see, if in the OR operation, you have 3 ones. So even if one value out of the 2 is 1, you get 1 as output. And it is different. So you have to have both the inputs as 1 for the result to be 1. Not, it just gives you the reverse. Any questions again till now? We'll go to the bitwise operators.
So when do you use for this not and other things? Can anyone give me an example? When a not operator will be used? Let's see whether you're able to think from the application point of view, whatever you're reading. If condition, okay. In if condition, when do you use for it? I mean, give me an example. So let's say, for example, I want to check whether Daniel is in KVIM or not. Okay. So if KVIM, let's say I'm declaring it as a small array or a list, I'm saying, let's say, to put it in simple terms, not relevant to Python. If I want to check if Daniel not in this list, I'll use a not symbol there and use that. So such kind of scenarios may typically come up in coding while you're developing something for a project. So that's when you use such operators. See, anything and everything that you're studying here, there is a purpose to it. Understand the purpose. What is the purpose of each and every operator? When can you apply? So we are just telling you the syntax and the practical, syntax and the application of it. But connecting the dots and applying it in the real world is something which you should pick it up as a skill. What you're gaining here is a knowledge. Skill is something you can gain only from experience, which you need to learn. Do you get my point, what I'm trying to say? Yes, no, maybe? All of you? No? Yeah, please keep your eyes and ears open so that you are able to pick these things as skills. Good. Back to you, Kaushal. Yeah.
Okay, sir. Thank you. So bitwise operators are different. So these you use when you have it basically first converts integer values to 8 bits format, right? So uh, it is again that is again binary format which is 8 bits. Okay, so this number 54 has been converted to these 8 digits based on again a base 2. So you can similarly see 66 uh, 8-bit format is this. So now to perform now bitwise operators perform the same operations we saw for AND or bitwise. So for each bit, if you use on A and B, we'll see now. Uh, just see the results in this table. So what will happen is now, as we saw, these are the 8-bit formats. Sorry for that. So now what is happening is if you do binary AND, which is this operator, it performs bitwise operation between A and B. So these are the 8-bit
Yeah, Kaushal, we are losing you, Kaushal.
you can see. So now for every bit, it will perform this AND operation. So as you saw, 0 should give zeros, right? Yes. Hello, am I audible?
Yeah, now you're audible, Kaushal. Perfect. Go
Okay.
ahead. In between,
Yeah.
there was a
So,
disruption. Yeah.
hmm, so again, it is what is doing is binary AND is performing AND operations for each of these bits. So zero, the first two bits, 0 and 0 will give you 0. Like right. Similarly, it performs AND operations for each of these bits one by one, and here you can see the results. So similarly, OR will give you this result. So you can see the second bits 1 and this is 0. So the output will be 1, right? So similarly, bit by bit, it keeps performing the OR operation, and you can store it in a different value, a different sorry variable. So the XOR, how it works is it just sets it just sees for it checks for one value out of the two, one of the bits, which is if it is 1, it will set it as 1, otherwise it is 0, right? So for the first, you can see first two bits, it is 0. That's why the first bit here as a result will be 0, right? So the second two bits, you can see one bit is 1. So that's why the result is 1 here. Similarly, if one of the digits out of these two is 1, you will get a 1 in the output. Otherwise, it will be 0. One's complement again is the reverse of what you have in the 8 bits. So if you do one's complement of A, you simply reverse this. So this will be 1100 1001. So you can see this result. Binary left shift again does it just shifts the bits by if you like see A, I have given this operator next and then 2. So A binary left shift 2 places will shift these values to by 2 places. So now this 1 will be at the front, like you can see, and the 0 1 will come after that. Similarly, every bit will be shifted to 2 places towards the left. So now this number, upon when you see your new convert this to 10 base integer, this will be the value 216, right? This is base 2, this will be base 10. So similarly, binary left shift to this operator, uh, can see double less than, oh sorry, it is greater than. So this operator will shift the bits towards the right. So this 000011, it will just add one more zero here, and this one will go to the right. So there will be one. This 11011 will be shifted this towards the right. So you can see now 111011 is shifted one place, right? Now this and it has added a zero towards the left. So this results to the value 27 in decimal.
Kaushal, can we take a break for 10 minutes now before we continue? It's 7:30.
Yeah, yeah, sure, sir.
Okay, participants, we'll take a break now for 10 minutes. Just have a quick coffee and come back. We'll continue from 7:40 again in 10 minutes, 7:43 max. Okay. Once you're back, just put it across in the chat window that you're back. Thank you. Okay, are we back? Yes, Aditya has asked the right question. Can we start again? Perfect. In the interest of time, we are just moving on to the notebook directly. So Kaushal, just take us through the notebook. And one request was, please open your notebook, execute this parallelly, understand every line of code that is written there. The purpose of giving you the notebook is you don't spend time typing it. But ideally, I mean, the best case scenario is you typing it and then doing it so that you make your mistakes and learn how to debug it. But since we are doing it remotely, it may be a problem for you. So we have given you the notebook so that you can execute and try it. So please make an attempt to understand what is in the code and how it is getting executed. Because just executing all the lines of code is very easy, honestly speaking. But that is not the goal for us. Our goal is understand each and every line of code, execute and check whether it is giving the expected results, whatever you are thinking in mind. Because your mind is also a compiler, right? Your compiler should have worked by reading the lines of code and understand. Like for example, if you look here, x equal to 10, x plus equal to 5, y is equal to 30, and this one. We have already gone through the presentation. Can you make a guess what that answer should be for the first line? Without executing, can you tell me? Without going to Python? That's how you should think ideally. Can you do that, please, while we are doing this? That's the only way to learn Python, boss. That's the only way to learn how to program. Okay. Back to you, Kaushal. Yes.
Okay, sir. Yeah. So please let me know when you execute the first one, so you can see the results here. If you see, the x value should be 15 because it is assigned 10 first, and then we are actually doing x is equal to x plus 5, right? So it is adding 5 to the already existing value of 10. So now new x value is x, sorry, 15. And similarly, y is assigned 30 first, and then we are saying y is equal to y by x, which is now the new value which will be assigned for y will be 30 divided by 15, which is the new value for x, because after this statement the value of x has changed, right? It has now become 15. So now this will be y is equal to 30 divided by 15, which is 2. Please execute this and let me know if I can proceed further and you have understood it. Okay, yes, we can move forward. So now these are simply arithmetic operators. So we saw the exponential operation, right? So now we are using the same variable y, which is now, remember, is having the value 2. So now 2 raised to the power 5 is 32. So if you run this, you should get 32. So everybody has understood this. So we can move to the next one. Any doubts, please ask me. Basically, y is being raised exponentially to the power of y. So to the power 5, right? Sorry. Y is having a value 2. So 2 to the power 5. So the result should be 32. When we print that, it should z, which is storing 32 now, should uh, give result as 32. Can we move forward? So if we see, now we saw floor division, right? So now value of Z now is 32, right? So 32 is been divided by floor divided by X, which is 15. 15 is the previous value for X. So this should uh, be stored in C. So any guesses what should be the value for C? Please post them in the chat box. You can also should be without executing. Right. It should be 2, as many of you have said already. So modulus operator is next. As we saw, it should give remainder. So previous value which we are using from when the X was changed, it was 15 and Y is 2, right? So it should calculate the remainder. So 15 divided by 2, as 14 is divisible, remainder should be 1. Please execute and verify. If you have any doubts, you can ask. So next, these are comparison values, comparison operators, sorry. So we are taking these values for like they are from they're being used previously. So C not equal to Z, exclamation and equal to operator, right? So it should give true if they are not equal. So as we saw C here being used previously, we printed C, right? It was 2 and Z is 32, right? So we are using the same values. So the print C not equal to Z, what should it print? Can you guys guess? Because obviously they are not equal. So you can see, yeah, it should give true, correct. And C greater than equal to should give false, right? As C is smaller than 32, 2 is smaller than 32. We are using a simple if statement uh, where we are using C less than equal to Z, so this will get executed as the condition is true, right? So print C is smaller than Z will be printed as the condition is true here. You can see first statement, as somebody told, was true. That was correct. And then as C is not greater than equal to, it is smaller. It is the second result is false. And third one for this condition, it is getting printed because C is less than 2 is less than 32. That is C is less than Z, and it is getting executed. If it was not the case, this will not get executed, this print statement. If only true, this executes. So moving to the logical operators again, we have just put one AND statement here in between. So we have seen AND, right? So just we'll use the same values for C and Z. So you can guess without executing as well what is the value. You can post them in the chat box. Okay, right. It should
I
be
mean,
false because
use your mind as a compiler, not Python notebook.
yeah, that will help. Yeah, because then it will be easier to understand. So C is equal to Z is false, as somebody already told. Uh, First output is result is false, and there is an AND operator in between. So uh, both the conditions should be true for this to be true, right? So if one is false, it will be false. The overall statement will be false. Similarly, this is OR. So not equal to Z here is true, right? Because 2 is not equal to 32. So even if 1 is true, this becomes true. That's the basic principle of OR. Similarly, we can, please let me know if you have any questions here. These are both, this is true because they are not equal, and this is true because C is greater than, sorry, less than Z, right? So as both are true, and statement requires both the uh, logics to be true, both the statements to be true. That's why this is overall as true. And not this gives you the reverse. So C is less than Z, that is 2 is less than 32 is true. So this should basically give false because it is not. That's about logical. Can you please all confirm if you have completed till logical operators? We can move to bitwise, or are there any doubts you have?
So are we done so far till line number 10? Yes, no, maybe. Okay, Aishwarya, Daniel, yes, thank you for the confirmation. Others, please. Okay, good. Please, let's quickly respond so that we can be on track. Nothing else,
Yeah,
boss. Go ahead, Kaushal. Yeah.
thank you guys. So next is bitwise operators. So these are again for our better understanding. We have used the same values from the presentation. So 54 8 bits format is written as this. 66 is written as this. So you can see and verify. So if you if you perform bitwise operation, which is this operator between them, you should get bitwise and results, right? So I'll just write what you will get if you do an AND operation between them. So you can see here that if you perform bitwise AND between each of these operators, 1, between 0, 0, 0, 1, 1, 0, 1, 1, you will get this result exactly. So as it is and, both of these should be 1 to get a 1 here, the second bit, right? So if that's why uh, we are getting 2 as a result, because it is in the second place as far as binary format is considered. So 2 to power 0, 2 to power 1, that's 2, is only 1. So others are all zeros. So you will get only 2 to power 1, 2, which is 2 as the answer. Is this clear? Because this is bitwise. So please let me know if you have any doubts here, or you are able to get the same answer. Are we done till here? Hello?
Yes, Kaushal,
Okay.
move on.
Yeah.
Yeah. So this is again similar binary OR. So you can actually do this. You can post the answer for this bitwise OR operation. You can see, I'll type your answer here. So you can post the answer in the chat. If I do bitwise operations between these two A and B, what will I get? You can post all the 8 bits in the chat box so that I can write. Right. That's correct, Harishri. So it's 0 triple 1 0 double 1 0. So in decimal format, decimal way, it will give you 118, right? And this is XOR, and this works as we saw. If one bit is 1, it will be set as 1. Otherwise, it will be 0. If there are two ones as well, it will be 0. There should be only one bit as a 1. So can anybody post the answer for this?
Um, Kaushal, just a quick suggestion. I think
Yeah.
it's
Yes.
better that we give 5 minutes time. Team, can you just
Okay.
quickly run through these uh, different lines of code that have been given in the notebook
Okay.
and ask us any questions if you may have, because taking it step by step, we are running behind the schedule. Just we are trying to save time. Can you just execute and ask us if you have any queries, if you're not able to understand?
Yes, sure. I'll do that.
Yeah.
So yeah, you're getting the answers right. So we'll quickly move on to others. So once complement, as I told, will give you uh, the the sign will change as the zeros will change to ones and ones will change to zeros, right? So similarly, uh, for binary shift, left shift, and right shift. These are the same answers we got in the presentation. Now this is membership operator. So how this will work is there are two strings, like one is belongs to and the other is this article belongs to me. So if I run them, you can see here, if I print X in Y, as you can see, belongs to is actually present in this string, right? So X in Y is the way you check membership for one string in the other. So this should give, as it is present in the bigger string, the substring is present here, it should give me true, right? Similarly, identity is when identity operators is to check if the values between two variables is equal. So if they are equal values given to two variables, X is Y is the identity operator, and that should give you true because these values are same, right? So now these are lists. We'll see lists now in the coming section. So as you can see, these values you can see in the list format, they are equal. So again, is should again give you true first. Okay, here what is the difference here is because they are lists and they are not individual variables, they are stored in different memory locations as we saw in the presentation, right? So these M is stored differently and N is stored differently. These 1, 2, 3 will be adjacent to each other in the list format. So that's why they are not really identical as they are stored in different memory locations. Memory locations should be same for is to give you true. Similarly, this is as you can see X I have assigned as 10, then Y I have given the same value. I've assigned Y as the variable X. So now they are basically same objects. So as they have the same values and they're stored basically the same variables when you do this. So similarly with this as well, I think this should also be same objects. Now operator overloading. Now this concept is when you use the same operator for two or three different kind of operations. So now you can see this is being used for addition. So C is equal to A plus B. 34 and 23 will be added and you will get this result 57. But the same plus operator as we have seen already can be used to append two strings, right? So string one is my name is, and if string two is Deepak Kumar, I can use string one and string two to append and store in a different string, and this should append these two strings. Now if I print this should be my name is Deepak Kumar. So here the operator is being overloaded as it is being used for two different purposes. Precedence is when so there are different precedence levels for different operator classes. So uh, so so they are executed based on the preference given to them. So if I quickly go to the presentation, so you can see the exponential operator is given the first precedence. So whenever it sees this will be executed first. And similarly, the levels go down. So there are classes. So in level 2, precedence level, we have all the BODMAS operators, multiply, divide, modulus, floor, division. And similarly others, then come comparison, equal. So as you can see, exponential is given first precedence. This will be executed first. So 2 to power 3 will be executed first and then it will be multiplied and the result will be based on that, right? Associativity comes when you have operators from the same precedence level. So like these operators are in the same precedence level. So now this BODMAS rule will be kind of applied. So they are in same precedence level. So now this statement Like if you see multiplied, modulus and floor division are in the same statement, so now they will be executed from left to right. That is the rule in Python. So if the operators from the same precedence level appear in a statement, they will be executed from left to right. So multiply and then modulus and then floor division. But this associativity rule you can actually override. It's the same principle from BODMAS. So bracket open is first, right? So if I use brackets here, as you can see, I've used bracket in front of 3, modulus b. So this will be executed first, and then it will go from left to right. So these were all the concepts I want to cover for operators and data types. Uh, and we have some assignment questions for you. You can try these.